Hello everyone. In the last video, we learned about function prototypes and how they can be used in order to let the compiler know all the information it needs to know about a function in order to compile code that calls a function. Before we learned about function prototypes, all of the definitions for our functions had to be above main and in the order in which they're called. Now with function prototypes, that's not the case. We'll list all of our prototypes in any order above main, and then we can list all the definitions of our functions below main in any order. Let's head over to the notes for today and learn about the advanced topics related to prototypes that we're about to cover. Specifically, we're going to cover how to make use of default arguments and how to overload a function. Let's set up a code base in order to start working with these advanced prototype topics. Go ahead and open up a file in gedit called advancedprototypefun.cpp, code up an empty main function, and then work on adding code for the following two functions. First, the roll die function is going to roll a six-sided die and return the result. Add a prototype definition and call for roll die. Then add another function called display roll result that will simply display the result from calling roll die. Have a prototype definition and call for this function as well. Go ahead and pause the video and work on the warm-up tasks. It's great practice. Since we're going to roll a six-sided die, I'm going to go ahead and add a constant that represents the number of sides of the die that we're going to roll. Now I'm ready to define a prototype for the roll die function. The result of rolling a six-sided die is an integer, so the return type will be int. And this function is simply going to accept no arguments at this time, but we will likely change this later. But for now, we'll always roll a six-sided die. Then for the definition, in order to use rand, we should also seed the random number generator. So we're going to need to add some pound includes at the top in order to do that. Now we're ready to call roll die. We'll need a local variable in main to store the return value from calling roll die. Now let's just see out roll for debugging purposes so that we can save, compile, and test before we move on to writing our next function, display roll result. So that looks good so far. Now we're ready to write our next function, display roll result. Display functions typically only display values, so they don't compute anything and they don't return anything. So we'll put void for the return value. And we've got to pass in an integer in order to represent what is the roll result that we're going to display. So this is a very, very, very simple function, but it still serves a purpose of fulfilling one task and one algorithm, so it is its own function. Now we can replace our simple debugging cout statement with a call to display roll result, passing in roll. All right, looks like we are done with the warm-up task. Now we're ready to dive into our first advanced prototype topic, which is default arguments. Default arguments are used when you want to assign a value to a parameter by default if an argument is left out for that parameter. So you only want to use default arguments when there is a value that makes sense for a parameter to be assigned. That value cannot be a variable unless that variable is constant. So it has to be a literal or a constant. You specify default arguments in function prototypes, and the default argument will only be used if the calling code omits an argument for that parameter. So let's take a look at an example of a default argument. It will help make more sense. Let's say we're going to add to roll die a parameter called numSides, which represents the number of sides of a die to roll. That way we can make this function more universal. Instead of always rolling a 6-sided die, we could pass in, say, 4 or 10 or 20 or 100 and roll a die that has that many sides. This is really useful for games that use a variety of different die sizes. For example, any of you who have played role-playing games like Dungeons & Dragons, D&D, there are a lot of different sides of die that are used in that game. So now instead of using 6 sides always, let's use the parameter numSides. Now, right now, our code won't compile because we've got a mismatch between the header and the prototype and the header and the call. But rolling a 6-sided die is the most common die that is rolled. It's rolled so often that perhaps instead of requiring the programmer to specify 6 sides as an argument when they roll the die, we'll just set it to be the default value for numSides. So the programmer can omit a number of sides for roll die, and when they do, it'll always roll a 6-sided die. But if they ever want to roll something other than a 6-sided die, they could pass in that argument when they call the function. So let's set up a default argument. So this is our default argument. We have a parameter of type int, and when no argument is specified for this integer, it's going to be assigned the value of 6 sides, which is 6. So this is really cool. We're not going to specify an argument when we call roll die, even though the function header says there must be an integer. Let's go ahead and compile this. It compiles, and it does in fact look like we are always rolling a 6-sided die. Let's copy and paste this. And this time, let's roll a 10-sided die. Adding these constant integers up here is kind of overkill since in the name we're specifying the value, but it's still nice to use these constants so that instead of seeing an integer number, we see more of an English description of the value. So I just declared one for 10 sides, and now I want to roll a 10-sided die instead of the default 6. So I'm going to pass in 10 via the 10 sides constant integer, and that value will be assigned to num sides on this call instead of 6 sides, the default value used on this call. And you can obviously see here that our second roll is in fact rolling a 10-sided die because we got an 8 and a 7, which are outside of the range 1 to 6 for our 6-sided die. So that was our small example of how to use default arguments. Let's take a look at the notes for some more information and some more examples using default arguments. All right. All parameters that use default arguments must be listed after parameters that don't use default arguments. What that means is in your function prototype, as soon as you start to use function default arguments, the rest of the parameters also have to use default arguments. So let's take a look at F1. Here in F1, we have a standard prototype that doesn't use default arguments, so that's valid. In F2, we have 3 standard parameters, and then we have a parameter that uses a default argument. Since this default argument is at the end of the parameter list, this is valid. F3. F3, we have 4 parameters, all 4 of which make use of a default argument. So this is valid as well. Now let's see some invalid examples that really emphasize this. Default arguments must be listed after parameters that don't use default arguments. All right, so we have no default argument and then a default argument, which means after we encounter a default argument, all of the remaining parameters must use default arguments. So that would be all of the ones to the right of this one. This one uses a default argument, but this one doesn't. And this parameter is what makes this prototype invalid, because you can't have a parameter that doesn't use a default argument after parameter or parameters that do use default arguments. Let's take a look at F5 and see why it's invalid. So we immediately have a default argument, which means all of the parameters have to use default arguments. So everything to the right of this parameter must also use default arguments. But we see that's not the case with the second parameter, B, which does not use default arguments. So this is invalid. Now, what we looked at here are prototypes where we're specifying default arguments. Let's take a look at some of the rules and examples for calling a function that uses default arguments. Let's say that this is our valid prototype that we're going to use in our example. We have parameter, no default arguments, parameter, no default arguments, and then 3 parameters with default arguments. When we call this function, all arguments that are after a left out default argument must be left out as well. What that means is as soon as you commit to making use of a default argument, all of the rest of the arguments must also be omitted so that the rest of the parameters to the right of the current one that you've left out an argument for also have to use default arguments. That's described with an example. All right, here we have a call to function f. At a minimum, we always have to provide at least 2 integers because the first 2 parameters don't have default arguments. So we've got 1 for a, 1 for b as required. And then we've got an argument for c, which is optional. We could have omitted this and used the default value of 1. Now, D and E do not have arguments for them, so they'll be assigned the default values of 2 and 3. Now we're on to this call where only a value is specified for A but since B does not use a default argument, this is invalid. The compiler will not compile this code. Here we have another call to F with 3 for A and 3 for B, which covers the two parameters that don't have default arguments, so that's good. C will be assigned 1, D will be assigned 2, and E will be assigned 3. Okay, here we have 4 for A, 4 for B, which those arguments are required, 4 for C, 4 for D, 4 for E, and then we have this extra 4 here. There's no parameter to store that value, so this is invalid. There are more arguments than there are parameters. All right, now we have 5 for A, 5 for B, and then it looks like the programmer is trying to skip assigning a value for the parameter C and wants to just use the default argument. Well, you can't do this because you can't skip an argument and then pass an argument. So the programmer here is trying to assign 5 to D, but based on our rule, once we start leaving out default arguments, the rest have to be left out as well. All right, now we're on to the last one. We've got the argument 6 for A, argument 6 for B, argument 6 for C, argument 6 for D, and there is not an argument for the parameter E, so the default argument of 3 will be assigned to E. All right, that wraps up our examples and our coding for our default arguments. Let's move on to function overloading, our second topic of our advanced prototypes lesson. Okay, function overloading, something that you've actually been exposed to but may not have realized it. Sometimes we want to perform similar tasks with different data types, meaning we want to call a function but pass in maybe a slightly different data type. We can do this with function overloading. 2 or more functions can have the same name as long as their parameter lists are different. That means that you can define another function called f in addition to this one if you'd like. The only requirement from the compiler is that those functions have to have different parameter lists. In fact, the compiler makes use of something called the function signature in order to distinguish functions. And that function signature is based exactly on the name of the function and the parameter list. So for example, we could have a function called square that squares a number that accepts an integer. And we could also have another function called square that accepts a double. Since they have different function signatures, remember the function signature is based on the name and the function parameter list, same name, but different parameter list, the compiler will say these have 2 different function signatures. I'm okay with you defining these 2 different functions that have the same name. Now, the function signature seems really similar to the function header and the function prototype, but the difference is the compiler does not care about the return type in distinguishing functions. So if you had a square function that accepted an integer and returned an integer, and you have a square function that accepts an integer and doesn't return a value, it's void, the compiler does not see those as 2 unique functions because they have the same function signature. So you would get a compiler error if you tried to write those 2 functions. So having a function that has the same name as another function but a different parameter list, meaning their function signature is different, is called function overloading. And like I said earlier, you've been exposed to function overloading but may not have realized it. For example, a lot of the functions in the CMath library are overloaded to accept different numeric types. For example, square root could accept a float, a double, or a long double. Even though they have different return types, the compiler doesn't care about that. It just cares about the function signature, which is these parts. So this is really nice because if we couldn't overload math functions, like square root could only accept a double, then we as callers of the square root function would have to do a typecast before we call square root. And here are a few more examples, such as print being overloaded to take a string, integer, or double, biggest to be overloaded to return the largest of two integers, two doubles, two longs, three integers, or four integers, so on and so forth. They have the same name, but because they have different parameter lists, the function is okay with you overloading biggest in these ways. Now let's head over to the code and let's overload a function that we've written. Let's overload display roll result. We'll add a second argument that represents the number of sides of the die rolled so that we can make our roll result cout statement be a little bit more specific. So let's do void display roll result int and int. So now I'm going to go ahead and simply copy display roll result and add another parameter called numSize. And I'll customize my prompt to say what number of sides of die was just rolled. So now let's call display roll result a third time. And this time we'll also pass in the sides. All right, you rolled a 2, you rolled a 2, and then this one says you rolled a 10-sided die and got a 7. So these two cout statements are coming from our original display roll result, and then this one, because we specified a second argument, caused our second display roll result function that we overloaded to be invoked. And that's why we get this more custom prompt here.